our holiday episode of The Flow. I am David Jones-Gilardi, joined as usual by my wonderful co-host, Carter Rabassa. Hello, Carter.
Ho ho ho! It is awesome to see everybody. Man, I love that we're doing this around the holidays. Any excuse to wear a silly hat is good by me. But as David mentioned, I am his faithful co-host of The Flow, and today, I mean, I've been wearing this T-shirt on I think every single edition of The Flow that we've done so far, and today is the official sort of MCP episode of The Flow. So finally,
It's come back around.
yeah, finally, like my investment in this T-shirt is paying off. But we're joined. We have an awesome guest today. So we're joined by Mihai Criveti. He is a distinguished engineer in Agentic AI at IBM. A good friend. A good friend of me and David's. We've gotten to know him over the last couple months. And most importantly, he's also the CTO and lead for MCP ContextForge. So we're gonna dive deep into what MCP ContextForge is, why it's interesting, why it matters, why developers are gonna love it. But Mihai, the way we kick off the flow with all of our guests is that we kind of forget about what our jobs are right now, and we ask you to go back as far as you need to, and tell us about the very first time that you ever wrote a program or wrote any code.
Oh, wow. That's going to go back quite a bit.
Nice. Love it.
We can have that competition and see who goes back further, right? You know?
Yeah. I guess the first thing that would qualify would probably be the Z80 basic, where I had one of these clones of a Z80 sometime in 1990 or somewhere about.
Oh, okay.
And then eventually I got a PC and started to write some proper software in like QBasic and GW Basic and Pascal and all these fun kind of programming languages. I actually like Pascal quite a lot.
What was my first real programming language was Turbo Pascal, and I also liked it.
Yeah.
That was when I was in high school. But I want to go back to this machine. You said it was a Z80. What was that? Like where were you living? How did you get this machine?
So I was living in Romania, so I'm Romanian, and we had our own version of a Z80. It was called an HC97 or something like that, a very fancy name, which came, of course, with cassette tape to load your programs, and those that were feeling fancy could splurge out on the HTC 2000, which had a floppy disk, so you could actually load your games on your Z80 Spectrum clone much faster than you would through the cassette tapes. But that didn't really last a lot. I got into a PC somewhere 286. I think 286 was my first machine, and that came with a proper MS-DOS operating system and QBasic and all the fun fancy programming languages, and of course Turbo Pascal, which came on free floppy disks, and later I think there was Borland Pascal, which was like the enterprise edition, 7 floppies.
Yeah, I don't know if you have as fond memories as I do of the using the tape loader, but specifically of all games playing Zork off of tape.
Oh yeah.
And so like you'd be like, you'd get an instruction and you'd be like, go east and go do this, and just like all of a sudden the tape had to go, and you're like do, and then it'd be like, you have come upon a door. It was just great that it was on tape. Like it just
they say real programmers don't write code using a keyboard. They just whistle it into a Z80 Spectrum microphone, and that's they.
I'm gonna have to go back. I'm gonna have to like look this up in Wikipedia. I'm not familiar with the Z80. My first computer was something called a Tandy 1000, which was a product they sold in Radio Shack, which is a defunct retailer here in the U.S. But it did come with a floppy drive, so I didn't have to add that on later. But Mihai, it's awesome to have you. And and honestly, it couldn't be a better time to have someone on with super deep subject matter expertise in MCP, because it seems like I can't get through a day or get through a conversation without something kind of coming up about MCP. So why don't I think why don't you kind of walk us through your personal MCP journey? Like, I mean, obviously, how many years have you been at IBM? Just first of all.
Oh, 18.
Excellent.
Close to
Okay.
18 years.
Yeah. So you've been at IBM a long time. So I'm going to assume that you have not been working on MCP these entire 18 years, right?
I don't think it's been around.
I know, but I think it's great to I think it's great to kind of hear from you, like, at what point did this technology sort of come onto your radar, come into your life? Like, what were the things that you were seeing, or the things that you were being asked to work on? So kind of like walk us through your personal MCP journey.
It was exactly 1 year ago, and I was home in Romania at my in-laws. My wife is also from Romania. I'm currently living in Ireland, and she took me home to my in-laws and said, "Hey, you're forced to take vacation. You need to take vacation. You're not allowed to do anything for work. We're going home for Christmas." And rather than going off and chopping trees or whatever else you had to do for the barbecue, I was like, I'm gonna look at something. And Anthropic came out with a blog on MCP, and I said, I'm going to do something with this. So I built the first version of ContextForge over Christmas, and I was playing with it. I was playing with the concept and kind of looking at how feasible it was to implement something like this and use it to replace what I've been doing with agents and tools and all these other kind of things using a proprietary protocol. So we've been developing agents for, I would say, more than 3 years, since kind of LLMs came out and started to become a thing. And as part of the journey, we've built our own agentic stack, and many of these agents, doesn't matter what you use, LangChain, LangGraph, AutoGen, AutoGPT, CrewAI, they all kind of had their own, even if open source, still their own, I would say, SDKs. And if you needed to build a tool to access GitHub and Google and Jira and Trello and Monday and all these kind of external systems, you kind of had to build it within the agent framework. And when MCP came out, they promised to decouple the agent framework from the tool, which, if it takes off, obviously it would have been a powerful concept. And back in December last year, it didn't really take off. Like for the first month, people were playing and experimenting with it. But sometime in January, March timeframe, we've already seen how it went from, hey, here's a couple of GitHub repos where people are playing with it, to hey, there's only 10,000 MCP servers available on GitHub. It's like, what happened? Like, the adoption was massive. So we've decided to adopt it at scale, deprecate our own internal stack, the one that we've been developing using our own proprietary protocols, and moved on to MCP. And moving to MCP was more difficult than we expected, because there were quite a couple of issues and problems in the protocol related to authentication and authorization and security and governance and all the other kind of things. So rather than trying to go fix the ecosystem, which was already impossible, by that time there were already 15,000 servers out there in the community. The gateway became the mechanism through which we can ensure things like observability, monitoring, security, governance, authentication, and authorization got addressed, and we put it in production. So that's kind of how I got to first play around with MCP. It wasn't designed for a serious project. It was more like a Christmas play. Think, hey, here's a blog, here's something Anthropic did. But the level of adoption has been absolutely massive. So, yeah.
Yeah. Well, I think I think you're being a little bit humble about MCP ContextForge. So I'm not sure, like, when the first sort of public commit was for MCP ContextForge. Do you remember that?
Yeah. So
like roughly, like, was, because like I know at this point.
So we have an open source process. So initially I've developed it privately, then I took it internally, made it available on our platform, took it through the open source process, and sometime I think in May we were able to push all those changes out within the external repo.
Yeah, totally. And I think I mean, at this point, I think MCP ContextForge is one of the fastest growing open source MCP gateways that are out there. I mean, there's a lot of excitement and energy in the space. And there's a lot of choice for developers, you know, and companies that are trying to deploy this kind of infrastructure. But yeah, MCP ContextForge is killing it, man. I think that you guys are over 3,000 stars already. You know, totally organic, right? Just like people discovering it, contributing to the project. It's just really great to see. I know that David and I have spent the better part of a year really just going deep on building agents and building AI enabled applications with Langflow. And like we've felt the pain of trying to, well, first we've experienced the excitement of MCP, right? Because one of the most important you know, just sort of set of features that Langflow has invested in the past, like I'd say, like 6 months, is its MCP capabilities. In particular, like its ability to function as a fully featured MCP client. So it's incredibly exciting. And then all of a sudden you have access to like really like single click integrations with, you know, thousands or tens of thousands of services. But then you experience the pain, right, of like, oh my God, like every service works a little bit different. You know, some support this, some support streaming HTTP, some don't, you know, and you sort of
work.
Sure. I mean, not all of them work. I mean, that's a yeah, exactly. You have challenges with the fact that not all MCP servers behave the same way or support the same capabilities. It's like one class of problems. You have another class of problems, which I kind of think of as like the registry class, where it's just like, geez, like you don't know who's running these things or whether they work or how reliable they are. Like no sense of like fallback, like what happens if this MCP server is not working properly. So I think David and I have like acutely, and a lot of the developers that we talk to who build on Langflow have kind of like, you kind of hit a wall where, you know, you have fun playing with MCP directly, like sort of like almost like you kind of like client server, right? Like, you know, you've got your client, you've got some server you want. It's really fun, and it's productive and it's fast. But eventually you get to a point where it's not scaling. You know, you're like, oh man, I've now added my 28th MCP server to my client. It's kind of starting to bloat. Langflow itself, like, is it's just always going to have a limited set of capabilities when it comes to managing those MCP servers, right? So it's exciting to see things like MCP ContextForge kind of come out and start to solve some of those problems, so clients can kind of thin down a little bit and go back to being what they're really, really good at. And then some of those classes of concerns can get moved over to something that's like a little bit more purpose built for it. So I think, so by the way, I think this is a fantastic time to show people what we're talking about. So feel free to share your screen, and let's kind of show people what MCP ContextForge looks like, what you can use it for. I'm sure as you're kind of running through some of these demos, David and I will have lots of questions.
Awesome. So look, let me just start with a demo and I'll give you a bit of an overview. So ContextForge itself is a application you can run, you can deploy it, you can have it on your machine, on your laptop, you can install it from PyPI or from our GitHub container registry. It's a one-line install, and once you have it up and running, it looks something like this. So here we go. So here's ContextForge. We have a REST API, we have a CLI, we have a desktop application. We also have a full-blown user interface, a web user interface. This is a web user interface, and you can kind of see here, you've got access to a number of capabilities. You have access to MCP, where you can add your own servers. You can create virtual servers combining tools from multiple MCP servers. You can access and test the tools available from those MCP servers. You can access the prompts, because some MCP servers come with prompts and resources in addition to tools, or you can create your own prompts within the library. You can access resources, configure routes, or you can access the MCP registry. So this is where you define the tools that you want to be able to bring to the platform. So here, for example, you can see we've got somewhere 81 different publicly available MCP servers. You can bring your own, you can customize its registry, you can make it your own. And by type of authentication, you can add them to the platform. So if they have no authentication, then you can just click on add, and that will just register that server with a gateway. If it has authentication, so let's say it has something like API key, then obviously you're going to need to provide an API key for that service. I assume you have one. We're not providing the API keys, so that's one of the unfortunate situations here. You have to pay for your own API keys if you're using a third-party service.
I think that's fair.
And we can just register it and make it available. So here you can see I've got, for example, the fast time server, which is running locally on my machine. So you can kind of see it here. It exposes 2 tools. I've registered 2 open servers. Don't ask me what they do. They were just open and available. And the moment these servers are registered with the platform, a couple of things happen. So first, for every server that is registered, we retrieve all the available tools, resources, and prompts. So here you can see, for example, for the server called fast time, we've retrieved 2 tools, which are called convert time and get system time. I can actually test these tools to see if they work. And I'm going to try to test this one, get system time.
Oh, so you can do that right here in MCP Composer.
Right here, you've got agent vision. So instead of going off and having to write some code or do it in Visual Studio Code or an MCP client or go off and do this within Langflow, you can just test here if the tool works first.
That's great.
So this is JSON RPC, is the protocol behind MCP, and you now have agent vision. You can see exactly what the agent would see. So you can see, for example, this tool is called get system time. It takes in one parameter called time zone, and it returns the current time. So if I provide, for example, Europe, Dublin, and I click on Run Tool, this comes back with the correct time for Dublin. If I provide, for example, New York.
EST. Oh, never mind. Do your thing. Oh, there you go.
We're going to see the different time retrieved here. And if I run it a bunch of times, I'm just going to keep running it a few more times, then I'll be able to see the data in the Observability tab, which I've disabled, and I'm going to enable to show you how our feature flags work.
Nice.
Okay, cool.
So you'll be able to see all the observability data within the platform as well. So here, for example, let me just click on View for a second. You're going to see that I've actually executed the get system time tool 32 times.
Nice. Now, Mihai,
and I can see
something fails. I see you do have failed executions there. When you're in that like agent view, right? Are you just going to get an error message or something? Like what happens in that case?
Well, let's see. I'm hoping one of these tools is going to fail if I don't provide it any kind of information. Oh, it didn't fail.
I see. It's an invalid. Just came back you can see something. Okay.
Yeah, the tool didn't fail. The execution didn't fail, but the tool came back with a response. So the difference here is failure means that I couldn't connect to the tool, or there was some parsing error, right? But in this case, the tool call was successful. I didn't provide any correct input for this, whatever this is. It's blockchain, but I'm not a big fan of that necessarily. And this information is provided to the agent. So the agent is the one that's actually filling in these fields. It's not a human, right? The agent needs to go in and say, if I need to write a Zeppelin contract, or if I need to go off and get the system time, I have a tool called get system time. I can see I've got a parameter called time zone. It takes a time zone input in this format, and it goes off and fills this information. So if this information is incorrect, then you still want to feed this information back to the user. So there we go. We've now generated an error, right? Because we've provided this information, and it came back and said, "Hey, unknown time zone," and then the PI filter actually detected that's information, and it censored out that information.
Well, and even though like the user isn't editing this or changing this real time on their own, right? The agent, I think the introspection is really useful, because I've totally run into cases of MCP servers out there that expect a certain type of input, but they're not very clear in their instructions, and some models get it wrong. And then you have to figure that part out, right? And so it seems like this, like I'm watching this, I'm like, oh, that would be super useful for a case where if you did run into something like that, right, where you could very quickly potentially find out like what is actually going on, what's going wrong with that communication.
Yeah, you basically get to see the same thing the agent would see.
That's cool.
So I've now clicked on View, and on View you can actually see the full input schema. So whenever you're building an agent, you're saying to a large language model, you're an agent, you have access to a bunch of tools. The tools include a tool called convert time. To use the convert time tool, provide input in the schema, and you can kind of see the schema here contains source time zone, target time zone, time. These parameters are required, and your agent is using the LLM to fill in the information. Here, your agentic framework goes off and executes that respective tool through MCP. The MCP server returns the data. The LLM processes the data. And if the result is, hey, you didn't provide the correct time zone, the agent can adjust itself. So it's going to go, let me try again. So having this input schema here becomes very useful. Being able to test it becomes useful, but also being able to go back to your development team or whoever is writing your MCP servers and say, hey, this MCP server is actually not verbose enough. Like the descriptions here are not correct. But in some cases, you may not have a development team, or you're using a public MCP server, which you can't control. So what do? Do you fork it and rewrite it? Probably not. That takes time. What you can do with ContextForge is you can click on the edit button. So this is one of the features we offer, where you can just make changes here directly. So you can change the input schema. You can change the description. So for example, get current time in the specified time zone. There we go. Let's fix that typo. And now the agent is going to hopefully find the right tool. Use this tool when doing X, Y, and Z. So you can change the input schema. You can define an output schema. You can even change the annotation. So for example, tools can be annotated as read-only, destructive, idempotent, open world. So you can make all these changes directly in ContextForge, and you don't have to redevelop your tool.
That's really, really cool.
Yeah, no, because like you could extend. It's like you could extend the functionality of whatever the existing tool is, or at least improve it for sure.
Or just speed up the development cycle. You could say, hey, I've already got access to the MCP server, but your development cycle will be go off and fork it, make the change, deploy it, reconfigure your agent. With this, you can do this live. You can make the change, see how the agent behaves directly within ContextForge. So you can either use the test feature here,
okay,
or we have another feature. I'm going to show you how to enable the extra feature with feature flags, where you can build an agent directly within ContextForge. You pick your choice of LLM, and then you're going to be able to test directly within ContextForge before you go live.
Oh, nice. Should check that out.
Okay, yeah.
Although I do have an initial question before we get into that. Have we so this is, I see very clearly how you can aggregate all the MCP servers that you're interested in. How do you then turn around and expose all of these MCP servers and tools like downstream to the client or to the agent that you're actually developing?
That's a good question. This is where virtual servers come in.
Right.
So virtual servers allow you to aggregate multiple tools, resources, and prompts from multiple MCP servers, A2A agents, REST API, gRPC, or other kind of APIs, and then only expose the ones you want to expose with their own API key. So here, for example, I'm going to create a new virtual server called my time server. This just tells time. And then I'm going to say, I just want to expose a tool, get system time. Or maybe I want to expose get system time and convert time. And maybe I also want get users. So this contains free tools from two separate MCP servers. In this case, I can also add some of the associated prompts, and I can add some resources. It doesn't have any resources. And when I click add, notice I've created a virtual MCP server with three separate tools, two prompts, and then I can export this to stdio. So this is what you would use, for example, with Cloud Desktop or a client that only supports stdio. And we have a wrapper that converts stdio to streamable HTTP or SSE and adds authentication. This is what you would do if your client only supports legacy SSE. And this is what you would use if you want to have streamable HTTP. And then you can generate your token. So you would go to API tokens, and then you can define who and how the access is provided. So I'm going to create a new key. I'm going to call it Mihai. It's going to expire in 30 days. I'm going to set this at team level as opposed to platform level, because the platform is multi-tenant. So you can actually create keys for multiple users. You can share your MCP servers, private, team, and public. And then you can, in addition, create an API key, for example, with different scopes. So I can limit it to a specific server ID. I can limit it to specific permissions. I can limit it to specific IPs. And then you use this API key within any client that you want to connect.
Mihai, what is the underlying API server that ContextForge is built on top of?
Oh, it's all part of ContextForge. So it has its own API. So if you can actually find all the information here.
Yeah,
so
no, I'm sorry. I meant
to,
like, is it a? This is so MCP ContextForge is a Python. It's a Python application, right?
It's a combination of Python and Rust. So we've developed a core in Python, but some of the components which require, or are need to have higher performance have been developed in Rust. So some of the plugins are Rust, some of the JSON parsing is Rust, and we're rewriting some of the strategic, components in Rust as well.
Okay, great, awesome, cool. That's all I want to know. But it's easily like packageable with things like Docker, and developers should be able to deploy this on just about any kind of infrastructure.
Yeah. So if you want to deploy it, I'll just direct you to our GitHub repository, and you'll see we kind of have a README. I'll just find a quick start guide, and I'll click on quick start, and you have a couple of ways to deploy it. So first, if you don't like reading and you have UV, you can just copy paste this thing and you're up and running. So it's one line deployment command. It's going to download it from PyPy, which is the Python packaging index. It's going to run it. You can, you have to provide a couple of options here, like what do you want to use for your email or password.
Right.
And then you're good to go. If you don't want to provide these things, you have to create a .env file, and we provide a .env.example. And then you can again use, pip or UVX, which is like the new way of doing things, and just have it up and running. If you want to do the same thing with, for example, Docker containers, we have a quick start here, which tells you how to deploy and run from Docker. And we have a couple of ways of running it. We can run it with Docker or with Docker Compose. And then if you really want to go all out, you have a couple of deployment options here. So I'm going to go to the docs. I'm going to go to deploy, and then you can pick your platform. Do you want to deploy this on Kubernetes? We also have a built-in Minikube with make targets. You can just spin up an entire Kubernetes cluster. Do you want to deploy it with Helm? Or even if you want to set up a CI/CD, we offer automation for Argo CD. So you can set this up with Argo CD.
Awesome, cool. Thank you for the whirlwind tour on all of the different ways that engineering teams can deploy MCP ContextForge. Like, this is super useful. I wanted to make sure that people that are watching this understand that this is a fully open source product with a lot of thought put into the different kind of deployment targets that engineering teams and developers are gonna have. So that this is awesome.
Cool. Let me show you a couple more features, because I've kind of walked you through the concept of MCP and virtual servers and how this works. But we also support A2A. So A2A is another protocol for agent-to-agent communication. There is some overlap between A2A and MCP.
Yeah, and actually, after you demo, and I'm sorry, I'll just tee this up in your head. Please demo the feature, but David and I would love to talk to you about A2A versus MCP.
Yeah.
Because this is something that as application developers, we've struggled with, because it does feel like there's a lot of overlap between these two protocols. And I just love to hear your perspective on when you would want to use A2A, explicitly use A2A, what can it offer developers or application teams that MCP can't. So, but yeah, please kind of show us how it works in MCP ContextForge, and then we can talk about that.
Sure. So just like MCP, you have an A2A agents catalog. You can register any A2A agent with the platform, and the platform is going to do two things. One is going to expose A2A through ContextForge. So you have access to all the plugins and guardrails and security and observability and monitoring and all the features. And second is going to allow you to convert A2A to MCP. So if you want to access your A2A agents as MCP tools, then this is one way to do it. And the moment you've added your A2A agent here, it becomes available as a tool. And then you're going to be able to turn it into a virtual server, just like anything else that comes from MCP. So now you have agents orchestrated as tools. So you can have agent-to-agent communication happening through ContextForge, and whether you're using A2A or MCP, you can just add it to your agent.
Okay, so it makes sense. So help us unpack like what A2A offers that MCP doesn't, because I guess I'll just sort of maybe, I don't know if this is like a hot take, but I honestly don't understand the protocol or the need for it. Basically, I think that I know that when I'm building agents, in situations where I imagine that I might want to delegate or communicate with another agent, it seems reasonable to me to do that through MCP and through like the metaphor of a tool, right? And in fact, we do that all the time. Like, you know, we'll build agents using Langflow. Langflow makes it really easy to expose those agents as MCP endpoints, and then we have this like pretty elegant communication between these agents, but happening over the MCP protocol. So yeah, I'm just curious, like what your perspective on that is. Like what more is A2A offering from a protocol perspective that kind of makes it worth it?
I think the way I would look at it is first within historic context. When MCP came out, it wasn't necessarily a very complete protocol.
Right.
It lacked a lot in terms of authentication, authorization. It didn't have a lot in terms of session and state management and resuming things. And the protocol itself hasn't received necessarily wide adoption within the first 2 or 3 months. So when A2A came out, it tried to address some of those issues, focusing specifically on agent-to-agent communication. It came back with an agent card, and it was designed to be more enterprise in nature. If you look back again, when MCP came out, it was kind of like the first days of Docker. If you remember, like the Wild West, everybody was building and deploying these Docker containers. They had them on a public Docker hub based on images that were never updated, images that were usually way too big, like gigabytes in size, with a lot of security vulnerabilities nobody was addressing. And while everybody within the open source community was using and playing around with Docker, very few within enterprises were able to adopt it. And it was only when private registries came out, when registry scanning and tools like, I don't know, Trivi or whatever that scan containers for vulnerabilities came out, and Kubernetes came out to better orchestrate and provide high availability to containers, that the whole thing took off within the enterprise space. And I think the same thing is happening with MCP. MCP on its own, when it came out, you know, yeah, you have STDIO, maybe SSE came out a bit later, and SSE itself, like, if you look at the first implementations within clients, it lacked authentication. And again, maybe it was in the spec, but not in some of the implementations, and all these kind of things varied. And A2A tried to address some of those challenges, looking at an enterprise setting, and didn't necessarily tackle some of the same challenges when it came to tool execution. MCP has seen a lot more adoption, but now it's at the point where some things are going to be available over A2A, other things are going to be available over MCP. This is where ContextForge comes in. You can just mix and match what you need. Personally, just like you, I tend to use MCP for orchestrating agent-to-agent communication as well. However, we've built our MCP servers with things like session management, state management, support for multi-tenancy, artifact storage, being able to resume and submit jobs, a virtual file system. They have the right authentication and authorization, and we present them in a catalog, and we add metadata to the way we present those MCP servers. And that's why it works. But if you try to do it with vanilla MCP from 1 year ago, then you're not going to get necessarily the same results.
Mihai, do you remember a protocol called SOAP?
Yeah, of course.
Yeah, I mean, I just sort of think A2A, it just reminds me of SOAP, right? Because like there's like nothing wrong with SOAP. It was like incredibly robust, and it had like lots of stuff going for it. It was just really, really heavyweight. The developer ergonomics were, I mean, it required like tremendous like tooling and knowledge to like, you know, actually like deliver SOAP sort of conformant services. And I don't know, I see, I mean, I'm happy to be wrong, but A2A kind of strikes me a little, it just reminds me a little bit of SOAP, and MCP reminds me a little bit of like REST. where it's like, yeah, like it's pretty simple, and there's ways to build awful and bad REST services, but the world is powered by well-designed and scalable REST services that our applications use every single day. So I think it's great that MCP ContextForge supports A to A, but yeah, I don't see it in the wild very often. I think what you're saying rings true. It's a very robust protocol, probably used in certain enterprise contexts. But I think I'm very bullish on MCP. It's kind of like continuing to evolve to kind of meet those needs.
If I were to expose my agents as a metered service to a third party, I would use A2A. If I want to call tools, including other agents internally within my application or enterprise, I would use MCP. That's the way I'm kind of approaching it right now. I do see a lot of the evolution of A2A also go in this enterprise setting. So they've recently released the AP2, which is the payment protocol, which extends the capabilities of A2A specifically to secure transactions and payments. Some of those things are not really something I would use MCP for right now. So I do think, to your point, it's got a lot more enterprise features, just like SOAP.
Yeah.
And it's definitely what I would use for exposing my agents, when payments are involved or when I need to have a secure connection to a third party. But for internal tool calling and execution, MCP is simple and effective.
Yeah, it's I think we kind of interrupted the demo of ContextForge. Like, I think you were about to show us plugins.
Plugins, awesome. So let me kind of tackle the idea of plugins as well. And I'm going to give you a visual just to support this. But think of plugins as guardrails that sit between whatever you have in ContextForge. So servers, tools, prompts, resources, A2A agents, whatever API you're talking to, and whomever is consuming those APIs. And this can attach with a pre or a post hook. So pre means everything that goes into that endpoint before it hits the endpoint gets filtered through one or more plugins. Everything that is a post means that once that endpoint has returned some value, so for example, a tool has executed, it's going to get again filtered through the plugins you set. So an example would be a rate limiting plugin, where whatever calls I make can be rate limited to a specific value, or content moderation using a specific service, or SQL sanitization to detect if there is potentially some kind of a SQL injection risk, or even something simple like a PII filter. So in this case, I've enabled a PII filter within ContextForge. I'm going to show you this filter. So here you can see, for example, I've set it to detect a number of specific values, and it's set to permissive, which means it's not going to block the request, but it's going to redact it with the text configured here as PII redacted. So I'm going to go to maybe prompts is going to be the easiest to showcase. I'm going to create a PII test prompt. I'm just going to use a simple prompt template. Hello, my name is, and then some arguments, and then publish this test prompt. So here you can see I've got a sample prompt, and I'm going to say, there we go. And you can kind of see that it's partially redacted the social security number sample I had here as an example. So it's pretty fast, and you can see this in the observability data. I'll show you in a second. And you can write these plugins just like an MCP server. You can write them in Python, you can write them in Rust, or you can write them as an external service, and you can attach them to any input or any output. And they can be used for a variety of things. One would be obviously for security guardrails, but you can be more creative than that. For example, if you use a large language model to generate JSON, if you've used very specific models, you know the pain I'm about to share, which is, please generate JSON in this format and give me raw JSON, and the model comes back with, sure, here is your raw JSON. I say, please stop saying sure. Just give me the raw JSON. And the model comes back and says, sure, I will now stop saying sure. Here is your raw JSON. You're like, just give me the raw JSON.
No conversations. Well, yeah, exactly.
Yeah. Funny. Rather than going through all that pain, you can have a plugin that strips out the information, identifies with a parser where the JSON exists, and then just returns that raw JSON. Or here's another fun example. Let's say one of your MCP servers return some data, like a log file, and it's big, like really big. It's 129,000 tokens big. So, more than the context window of your mall. What happens? Well, your agent is just going to crash. So what we can do is we can insert a MapReduce type summarizer inline, where if it detects that a specific input is about a certain threshold, what it can do is it can MapReduce it, so it can split it using some kind of an abstract syntax tree notation to split it depending on the type. So if it's, for example, Markdown, is going to split it by header. If it's HTML, again, by section. If it's a PDF, it might convert it to text and then split and chunk it, just like a RAG solution, right? And then it's going to take each of those chunks, summarize each of those chunks, and then do a summary of the summaries. And then the agent is just going to get 1,000 tokens or 10,000 tokens instead of 100,000, and it's not going to crash. So you can do all of this within the plugin ecosystem, and you can address another limitation you've mentioned. I think you've mentioned, like, what happens if I have 30 or 40 or 50 or 100 tools?
Oh, sure.
Well, right.
The agent is going to get very confused.
That's right.
First, and second, the agent is not going to work at all if your tool definitions exceed the context window of your mall. So what can you do? Well, again, you can create tool groups, and then using either semantic search or cosine similarity or another LLM or other approaches, you can filter those tools or have tool groups, and then ContextForge can kind of intervene and translate that one tool call into potentially 100 tool calls behind the scenes and give you the right input. So let's say, for example, you have an MCP server for GitHub, and it's got tools: GitHub issue create, GitHub issue delete, GitHub PR create, GitHub PR delete, GitHub PR list, GitHub. So it's got
a ton of them.
Dozens of tools.
Right.
Every single one of those tools comes with this: a tool definition, with a tool name, with an input schema. All of this goes in your context. So all of this takes up time, money, and precious context, which once filled, everything stops. So instead of exposing 100 tools, you could expose, and if you need to call GitHub, call this GitHub tools, just this GitHub tool, give it what you want, and it will figure out what to do. So behind the scenes, we're basically turning that into an agent, which is going to, again, do its own tool execution and call the right tool based on that. So there's a couple of things you can do with this. We also have a plugin, an external plugin, which connects ContextForge to OPA, which is a policy agent. So you can write a regular rule where you can define with the open policy agent, OPA. It's not the LLM type agent, it's just what that project is called. You can write kind of like a firewall rule for these tools. So you can say, for example, and this is something that actually happens. People write tools like kubectl. It gives you access to the kubectl command, which seems like a great idea until you realize that command can be used to delete an entire Kubernetes cluster, which you may not necessarily want to give to your agent. Or somebody created a tool for SSH or Bash or Shell or whatever. And then obviously the LLM would be able to put any information in there. First, if there's a user controlling that agent, they now have access to whatever permissions the tools has, right? And second, the agent itself can get confused. And we've seen all of this, like, there's tweets of like, hey, I'm using Copilot this or some Visual Studio Code plugin or client or continue or some other agentic platform. I'm writing a project in my home directory. And I said, hey, can you please fix it? And the LM goes, sure, let me delete the project and start over to fix it properly. And then nukes their entire home directory. You can prevent these kind of things with the right policies in place. So you can put an OPA regular rule, which instead of trying to block, you allow. So you say block everything, and then you allow specific actions on top of it, just like a regular firewall.
Can you show us what this would look like?
I can, but I don't have OPA installed, and I'm not going to do it right now. But you have to write an OPA policy rule. So it's an external dependency. So you have to deploy OPA, and then you connect it to ContextForge. We have a plugin that connects it, and then you have to go and write one of these firewall rules, and you can define it.
Yeah. Is there an example of what it looks like to make to code any of these plugins, even a very simple one? It doesn't have to be the OPA one. I mean, it could be like something even just.
Yeah. So to write one of these policies is quite easy, and you can go to the Open Policy Agent website and you can find these policies. But to write one of these plugins,
yeah,
you
the
just
plugins.
write an MCP server. Yeah, we have a templating tool, so it uses a templating engine to instantiate one of these plugins for you to write it. But if you know how to write an MCP server, you know how to write a plugin, because the plugins are MCP servers themselves. We're using the MCP specification to write the plugin, and we're just attaching these hook points to them. So you can find all of this in the repo. So if you go to the repo, you'll find one of these plugins, and you can see we have plugin templates, which is where we have that tool. So you can see external and native. External is literally an MCP server. So this is just a Jinja-based template system. We will have a tool which instantiates that repo for you, and you can just go off and write it. But basically, it's literally just a MCP server.
Is it just like MCP tools with hooks, essentially?
It's MCP. It's an MCP server with hooks. Yes, and then you need to import this, and then you can define where these kind of get attached. So if you know how to write an MCP server, you know how to write a plugin. And you can kind of see we have the plugins themselves. These are the Python-based plugins in the directory called plugins, but we also support Rust. So if you want to write in Rust, then you can see, for example, we've got a PII filter, which is based on Rust, and it just filters out PII.
Yeah, I mean, I'm really fascinated by this, because I think that I just think that a lot of developers, I mean, look, honestly, I've never seen a more sort of rapid deployment of new technologies and best practices and techniques like within our industry, right? I mean, this is all happening in a very compressed time frame, and it's changing constantly, right? So like what it looks like to build an agent today is different than what it looked like 6 months ago. I think that like one thing I've noticed is that developers, as they run into problems building agents or building these applications that are almost entirely based on the fact that LLMs have this non-deterministic behavior, or have these limited context windows. I've noticed that like one of the solutions is like to working with LLMs is to like throw more LLMs at it, sort of like, which is fine, which I think for certain use cases is fine. But like this, I love like this. Sometimes I love that the answer is like use less LLMs, right? Like actually go back to statically defined code. In this case, written in highly performant Rust that knows what a social security number looks like, and then just like with incredible performance and incredibly low cost, is solving some of these problems, right? Or it
doesn't have to be a regex. It can also be a regular AI model. So you can use an LTK, for example, or scikit-learn, or some of these libraries, or ChemSim, to just use one of those libraries for identifying PI data. The difference is that it's going to take 0.1 seconds versus 5 seconds for even a small model to make that identification.
Right.
Yeah, no, agreed. And then as engineers, like there's this unbelievable spectrum of like, I don't know, like almost like assembly level statically defined code. And then here at the very, very top is like, working with GPT 5.2. And then there's like just the spectrum of code, small models, and then like, so then the thought process of like, how do I architect my agent? How do I build it? How do I think about like at what level, like where does business logic live, and like how do I choose like what to use? Like these things are actually like non-trivial problems to figure out, because obviously David and I build a lot of in DevRel, like we build a lot of like kind of trivial applications and demos, but when you get into like real complex systems and software, like I can imagine like how hard it is to reason about these things, right? To even feel confident that what you're designing and what you're proposing is like the right way to do it, in a way that I don't think people felt like. I think as pre-AI, I think people felt pretty confident about how they were designing SaaS applications or like more familiar kinds of software. And I think that now, but I love what I'm seeing here. Like I feel like this MCP kind of gateway and proxy is a really like reasonable place to house certain kinds of logic so that your agent becomes simpler by definition. And in some ways, like the MCP, the downstream MCP servers can become, simpler because like the proxy is taking on some of the responsibility for performance or for like sanitizing things. I don't know, this is really cool. I can just see like a lot of usefulness here.
Yeah. And and I have a question, Mihai. Like, and there's all sorts of capability that you're showing us, and I could see over time, like at my company or for my app or whatever it is that I'm using ContextForge for. Let's say I've added a set of plugins. Maybe I'm using ATA over here, but I've got, like, say, a virtual, MCP tool that I've created that is a combination of like 5 other tools, right? And I've kind of curated what tools are available and all that. At some point, and I wonder if this is going to get into the metrics part you were kind of, kind of pointing at before. At some point, I'm going to want a holistic view on all of those things and where they're being used for, like, say, my enterprise or my app or something. Does ContextForge have something like that where I can get that high level view?
Yep, sure. Let me show you some of the...
By the way, I have no idea what the answer is.
So let me show you some of the makefile targets we actually have for ContextForge, because we do have a lot of feature flags within ContextForge. So many of the features can be enabled and disabled on the fly. So let me kind of show you the .env file. And you can see here that this allows you to kind of change everything about ContextForge, how it's deployed, what features are enabled, what features are disabled. So one of the features I'm going to enable now is observability. So you can kind of see that observability is enabled. And another feature I'm going to enable is LLM chat. And you can kind of see here LLM chat is enabled. So these two features allow ContextForge to spin up and now provide you that observability data for every request you make, but also to build AI agents directly within ContextForge and test them and see how they perform. So that gives you that additional capability. And you can kind of see everything here is configurable. So for example, for the observability, we can send the observability data to your chosen observability platform. So we support OTLP, Yager, Zipskin, or other kind of protocols for sending the observability data. So if you have something like Arise Phoenix or your own platform, we send that information out. If you don't, you can see the same information within ContextForge. You just need to enable the other feature called observability enabled, and this will start logging that information. It's disabled by default because when you run it as a regular local user on your development machine, you probably don't want to start collecting, potentially hundreds of megabytes of data, just, logs after logs after logs. So it's feature flagged. So now that I have it up and running, I have it there. I can just run the server locally. I'm not going to rebuild or run a container. I'm just going to run this locally. And if I see it here,
I see observability magically showed up there.
Yeah, there's a new tab here called observability. And this gives me that additional information. So I can see everything that goes into the platform, and I can kind of see the request. I can see the time it takes. If there is a PI filter, I can see the input. I can see the output. And the other tab that showed up here is the LLM chat. So with LLM chat, you can kind of have a conversation with the virtual server. So it kind of builds an agent automatically for you. So you go to LLM settings, you add a provider. You can add any of the providers, OpenAI, Anthropic, Kolama, Grok, Mistral, any of these other kind of providers. You save it. You can test the model works here. And then you can have a chat and build one of these agents on the fly. You see how it performs. Then you go to the observability tab. You understand what's going on, if there's performance issues, if it's sending the wrong information. You go to your tools tab. You make some changes to edit how those tools are described. And then you go back to the agent and you see, is it picking up the tool now? Is it making the right tool call? So you have all that information. And if you want to go one step above that and you want to see some evals, we also offer an eval framework that comes with ContextForge. So you go to our repo, and under MCP servers, go to Python. And you see here, there's quite a lot of MCP servers that come with ContextForge. And there is one called MCP eval server, which gives you 63 different evals you can use. So things like, if I can give you an example here, how are my agents performing? Well, you have LLM as a judge. into multi-judge consensus, which is when you ask him, hey, ChatGPT, is ChatGPT doing well? ChatGPT is doing well. Well, obviously you're going to get that answer, right? But if I know it's an OpenAI model, but the idea with multi-judge consensus is you ask multiple models and then you average them, right, to avoid bias. Or you can evaluate the prompt. It's like, my agents are performing very poorly, but the users are typing in the wrong prompt. Well, that's probably the issue, right? Or you can evaluate the agent tool usage. So is the agent actually able to select and use the right tools? You can evaluate the quality. You can evaluate specific types of agents like RAG-based agents. You can evaluate bias, fairness, robustness, safety, alignment, multilingual competency, performance, privacy. So all these things can be part of the evaluation. And of course, you can run this as a plugin as well. So now you have the ability to evaluate how your agents are performing. And because this is an MCP server, you can even expose some of these calibration tools to the agent itself. And the agent can do a live eval. So it's going to be, let me try to give you an answer on this. Right, I found the answer before I send it back to you. Let me check. Oh, the eval says this answer is terrible. Let me try again. Oh, the eval says it's good. Here's your final answer. So you can kind of do one of these in the loop evals as well. That's why this is built as an MCP server.
Awesome. So I'm looking at the clock and I'm realizing that we're just about on time. Mia, this is MCP ContextForge is super cool. And I'm actually kind of shocked at how robust and just like filled with features it is, given, I mean, the relatively short time frame that this has been out. Yeah, this is awesome. I mean, I think for anyone who wants to download it or check it out, where should they go? There we go. Awesome. Yeah. So folks, if you're sort of watching the podcast, and we hope you are, because otherwise you're not seeing me and David's Santa hats. Feel free to scan that QR code, or just go to GitHub /IBM/MCP ContextForge. That's the best way to get your hands on it. Awesome.
Just to make it clear, it's a fully open source Apache licensed project. You can download it, you can use it. And we've just announced release 1.0.0 beta 1. So we're getting ready for the 1.0 GA. If you go to our developer works, developer IBM.com blogs, you'll find more information about what this release comes with and some of the features and capabilities. And one of the things we're also announcing is our desktop application. So if you don't like the web UI and if you can be hassled, we now have both the CLI and a desktop apparently that you can use.
That's amazing. So the only thing you need to build now is a TUI, because like apparently developers are.
I love terminals myself. We have that. So I get excited about those.
that's part of the desktop client application.
Oh, is it? There's a TUI built into it. Nice.
Yeah, it comes with a command line client which has TUI features in it. So it's not full TUI, but it's got like tables render.
I was kind of kidding. Like I'm kind of shocked at how TUIs have like turned into a thing. I'm not actually, honestly, I'm not even sure how I feel about them. Like I like classic CLI. Well, I like CLIs in the sense that like, they're kind of like, they fit into the Unix way of building things, right? They have input, they have output, you can chain these things together. Like these TUIs, I'm sort of like, I'm not really sure who they're for. But I'm also, I don't know, I guess maybe the younger devs are into the TUIs. So you gotta keep up.
Screens. Like to me, I love the second I go into a TUI, I'm like, oh yeah, I'm home, right?
It's so funny.
Yeah, you can run it in tmux or your terminal multiplexer of choice, and it's always there. It doesn't crash with the server. You can run it over SSH. So I think I like this. I like that you can run them remotely. So that's probably the biggest.
Oh, that's a good call. I guess I'm a little bit too married to web applications and web dev. But Mihai, thank you so much for joining us. This is a really awesome conversation. I think it's just never. It's such an exciting time to be a developer, to be an AI engineer, to play with things like MCP, to watch MCP evolve like at the rate at which it's evolving. So yeah, I think folks should definitely check out MCP ContextForge. Thanks so much for joining us and giving us a whirlwind tour and sort of tolerating my hot takes on how A to A is just like so version V2. But yeah, look, thanks so much for joining us, and we hope you can join us again.
All right, awesome, pleasure to be here. Have a great day. Bye.
All right, later, folks. Bye.
For joining the flow. See ya.